Let's see this process together with an example. Suppose we have a network with 3 subnets. There is a DHCP server for the subnet 223.1.2.0/24 network, which is on the address 223.1.2.5. A new laptop arrives at the subnet. It connects to the Wi-Fi access point with address 223.1.2.9. When this host comes into this network, it first broadcasts a DHCP discover message, trying to find the DHCP server. It sets the destination address of the datagram to 255.255.255.255, which is the IP broadcast address. It sets the source of the IP datagram to 0.0.0.0, the default address. In the next step, the DHCP server broadcasts a DHCP offer message, announcing an IP address that could be used by this endpoint. The datagram still has the destination IP address as the broadcast address, which has all 255s. The source address of this datagram is the IP address of the DHCP server, which is 223.1.2.5, and it contains the offered IP address in the body of the message, which is 223.1.2.4. Then, the client broadcasts the DHCP request. The IP datagram still has the source address as 0.0.0.0, since the IP address is not assigned to the endpoint yet. The DHCP message contains the requested IP address in the message, and the DHCP server responds with the confirmation message, which is within a broadcast datagram again, which contains its address as the source of the IP datagram, broadcast address as the destination of the IP datagram, and the confirmed address at the body of the message as a part of the parameters. DHCP provides more information than just allocated IP addresses. It returns the IP address of the first hop router for the client to connect to the internet. It can also return the name and IP address of the DNS server, and it returns the network mask. The configuration file at the DHCP server can also be used to provide links for automatic upgrades and plug-and-play software downloads from the network. One question that might come up is that where in the protocol stack is the DHCP protocol? It runs as an application protocol which uses the UDP protocol for the transport layer. So, for example, when you connect your laptop to a network using a Wi-Fi access point you connect to, your laptop needs an IP address with subnet mask, address of the first hop router, and the address of the DNS server. It will use DHCP for receiving these information. The DHCP request will be encapsulated in UDP, then in IP, then in 802.11, which is the Wi-Fi data link layer protocol, and sent over the wireless link. The Ethernet frame will be broadcast on LAN, which we will see the details of its working in the data link layer discussions, and received at the router running the DHCP server. It will be demuxed to IP, to UDP, and DHCP at the server. DHCP response from the DHCP server goes through a similar process. Server encapsulates it using UDP, IP, then link layer protocol with the same process and sends it to the client. Decapsulated again at the client finds out its IP address and the other information from the application layer message of the DHCP. This figure shows request and reply messages for a DHCP communication. You can try capturing your own DHCP messages by running Wireshark on your laptop while connecting to a new Wi-Fi network.